Happy to be here and present on what we see as some of the future of heavy civil and infrastructure. I guess before I get in the future and when we look to the future, I like to look to the past a little bit, see what kind of indications we can get from what we've witnessed, what we've learned, and how that may help to predict the future. Something that I've thought about often is, will my generation see the advances that my grandparents' generation did? And they were all born just after 1900. And, the changes that they saw were incredible. If we talk about what happened with transportation, what happened with entertainment and how things changed from, early records to the radio to television and being able to see someone on the moon and what happened with computing the 40s 50s 60s with some of the biggest computers and later in their lives seeing actual personal computers, so some incredible advancements there. What do we take from it? I look at myself and professionally over the last 30 years, what's happened with me with communication. And I think I've gone through every single one of these devices and how we've got the power so much at our fingertips today here now, how we're able to communicate with the world so seamlessly, and what we're able to do with the computing power in our pockets. From a computing power standpoint too, I've gone through the evolution of all of these kinds of systems, from working on VAXs originally and different types of workstations and the first PCs into the first laptops, and as we got into the internet and just email, and now what we do today with Teams and conferences like this. The evolution has been incredible. From a professional software standpoint, I started off early on as a developer working on Ashtoware products. First one was the bridge analysis rating system, and today we look at 2D plans and 3D models and digital twins, and this 30 years ago is what we were looking at with textual input to define a single beam in the structure and to define parapets and the overall spans, and then how we use that for the bridge rating that we did. Similar thing on the road design standpoint, how we use textual input like this to define alignments and your curvature and points of tangency. And then we got into being able to work with things from an interactive graphic standpoint, where we could see cross sections and our side slopes and understand a little bit more. We combine those things together, and we kept, we've continued to iterate through to be more interactive and more graphical and more model based. And we see, really detailed 3D models that we work with today. That's allowed us to work with things like automated machine guidance and having, automated control of construction equipment that's out there. And now we see the Federal Highway Administration really trying to help push this along too, and push us into full model-based delivery, where the entire life cycle, from design to construct into operations and maintenance, that we'll see a full model-based future. Now, going into this, then, as any good employee or per human today, when you want to understand what's happening or start a presentation, first thing we do is go to Chat GPT, right? And so I asked Chat GPT what it thought the future of heavy civil was, and I got this response back, and it contains some notes here: sustainability being important, smart infrastructure, climate resilience, and urbanization. And he said, that's okay, but how about a little bit more? What about the biggest trends and challenges and opportunities? And so it came back with some more talk about sustainable practices and smart technologies, and more on resilience, the issue of funding constraints, issue of environmental impacts, what we're doing with construction methods and leveraging data. I thought pretty good. As a company, we've been trialing Microsoft's Copilot, and so I said, let me see what Copilot says. And so I asked Copilot in Microsoft Word what the future of heavy civil and infrastructure is, and it did a pretty thorough job. It came back with what takes up 2 slides here as a response, and similar types of focal points, though. What's happening with population growth, urbanization, climate change? How do we need to work to address that? The trends that it just automatically came out with digitalization and AI and big data, the Internet of Things and blockchain and understanding about green and resilient infrastructure and smart and connected infrastructure. And it continued on with challenges around financing and workforce and regulations. And so I think that that gives us a great place to start and a number of things to hit on here today and for all of us to look at. As we see, though, we can't be 100% dependent on the likes of ChatGPT and AI and automation. And this Twitter post just really raised that up there. Hey, ChatGPT, finish this building. Can't do it. There's some skills that are irreplaceable, and I think that the future will see that continue definitely. As I look to summarize some of that, then we look at challenges here. What's happening with urbanization and population? What's happening with climate change and other environmental impacts? The funding, the workforce, and a lot of regulations and standards having to work through with EPA or whatever like there. What do we see with the trends and opportunities there? How we work with sustainability and smart infrastructure, and how we design and develop for resilience and efficiency, and look at new construction methods, and then definitely the technology. So, I think that a lot of this is on all of us. How do we create? How do we collaborate? How do we innovate? And what limits do we have? Now, when I go and take apart some of those challenges and some of the trends that we see here, and really try to provide that insights into this, look at things like resilience and innovation and regulation. We saw in Southwest Florida, the late September of 2022, Hurricane Ian came through, massive destruction. Here's some pictures of the Sanibel Causeway. It's 3+ mile bridge that connects the mainland out to Sanibel Island. And there was about 16 feet of storm surge in this area. The structure was resilient overall, but there was 3 spans that were adversely affected by the storm, and the island was cut off from road transport. The amazing thing here, with the resilience, with the innovation that comes into play here, and this is just from a remediation standpoint, but we saw the hurricane come through September 28th. 2 weeks later, October 12th, those spans had been repaired, and those structures were open to emergency moves. And 3 weeks later, totally after the storm, the causeway was open to the general public, or to the residents there, not the general public overall. It took so many people. They said 100 crews worked around the clock. You look at the amount of dirt and rock and 4,000 tons of asphalt that were brought in. But in time of crisis, we found that way to innovate. We found that way to get past regulation, past funding processes and procurement, and we just made it happen. So we can do it when we want to. Just a similar kind of example here. We saw in Philadelphia the I-95 bridge collapse, and there's a tanker truck started on fire under the bridge. We lost that structure. June 11th of 2023 that happened, and in 12 days that structure was open. It wasn't open in its original form. It wasn't all the beams. It wasn't the same design. It wasn't a long-lasting solution necessarily, but it allowed us to deal with this area that has 160,000 cars cross through that area every single day. And again, it was the extent of work and coordination and collaboration and planning and resilience that would go into this. That different methods with lightweight glass nuggets, and using the Pocono Raceway track dryer to speed up the asphalt drying process. So we can do things more quickly when we're really driven to. When we look at trends around sustainability, there's a really interesting organization called the Ray, and they're looking at all kinds of things that we can do in our roadways to better prepare for the future, to be more efficient, to be more energy, to be more nature friendly. And so one of the big things that they're touting, you see in the picture in the bottom left there, is to try and use the right of way inside of interchanges to install solar developments. And they say that if we looked at doing that, we would be able to power 12 million electric vehicles a year by the power that could be generated by putting solar developments inside those interchanges. They light them up. They say it's safe. and just a good way to look at land that doesn't go use today. And they've got several other things for pollination meadows and what we need to do with better pavements and being more sustainable overall. We look at greenhouse gases and what we should be doing and what opportunities we have to take into consideration when we look at new designs. I know we've been working with an organization called One Click LCA Limited, and we're able to take models and see the impact of the materials that are used, the design that's used, and identify exactly the extent of greenhouse gases that come into play because of that specific design consideration, whether the form or the materials. Yeah. Looking further out into the future, I think that we'll see heavy civil and infrastructure impacted by a couple main considerations, and that is one, new designs. That we're looking at new designs for livability or sustainability or resilience. And then we look at new methods for how we address those designs and the construction that has to come into play. When we look at a couple examples here of how far the new types of designs can be pushed forward, how much we're going to be challenged. These pictures are all from the Arch Out Loud design competition, and they put on different design competitions. This specific one was for Miami floating housing, and they challenged participants to look at what could be done to put housing in this water area of Miami. And so you can see all the different crazy designs that come into play. This will result in so many changes that are required and how we deploy our equipment and what equipment's needed and what we do with the building materials and what we do with our building methods. And that's in an area close to home for most of us, Miami in the U.S. We see some really, really crazy things going on in the likes of Saudi Arabia, a couple huge projects there. And I want to just share a little bit there and see how that will go and challenge us. So I'll let this one video play, and then I'll come back in and show a couple other projects that they have going on.
Introducing the new horizon for Riyadh, a new icon, the Mukaab, the world's first immersive experiential destination. A gateway to another world. Step inside and it's unlike anything you've ever seen, at a scale that's unprecedented, big enough to hold 20 Empire State Buildings, where you and those around you.
So you can look up that project Mukaab. I mean, crazy. They're thinking about 20 Empire State Buildings in that space. But NEOM has several projects going on in Saudi Arabia. One they call the line here, and the line is 200 meters wide, 500 meters tall, and goes on for 170 kilometers. If I did the math right on this, that will be over 200 of those Mukaab cubes. This is massive. We look at what they try to do, and they try to put all kinds of business and residential and lifestyle activity type capabilities inside of these individual modules, limiting the amount of time to travel for anything that you would want to do, but that this goes on for 170 kilometers. And you can see a couple pictures here of what they see this design being overall. They're also working on the Oxagon, the largest floating structure in the world, which will be 100% clean energy based, a luxury island, and something that's going to be used for a whole bunch of upcoming events, this Trohena, where it's this mountain and they've got snow skiing in Saudi Arabia. But you can look at the design that goes into play there and the wavy aspect to everything and what's going to happen with the tools that are used for the design, methods for the construction, new equipment that's going to be required. My company likes to talk about building infrastructure better, and we talk about that from plan, design, build, and operate. I think we not only have to talk about better, but being different and for the future. And there's a lot that needs to change for that. We have to be more efficient. We have to be more digital, and we need to look at more integrated methods throughout the entire life cycle. Gone are the days of huge rooms of drafting and walls of plan sheets, and the need to get to models that go and really provide a better understanding of the entire project. Where we work with a model like this for design, we use a model like this for planning our construction, for looking at any kind of collisions, conflicts that can come into play, where we understand the materials, the timing of material delivery, the movement of equipment around on the site, everything that comes into play to adequately, efficiently construct such infrastructure. The other big benefit of this then is that once we have a model like this can be used for the design and construct stage, it can then come into play for the whole operate stage of life. And we hear about the 80-20 rule, 20% the cost on design and construct, and 80% for the operation of an asset over a lifetime. And so having that information, being able to work with it over time is just as important, maybe much more important even than what we do with our construction processes. And we see the exact same kind of tools coming into play and being available for horizontal infrastructure, where we work in the road design and we have that model and we can deal with all the details and all the timing and all the project management and coordination that comes into play, while also still allowing the engineers to go back to the means and methods that they're used to, and working with cross sections that we'll see come into play here, but having more detail and more of a model based approach overall. With all of this, it's about technological advancement. We push all the time on trying to have our work deployed faster and faster and faster. And so, a chart here just of what has happened with communication devices, and what we see, how long it took for the initial telephone to gain mass appeal, and computers, and how smartphones just blew that away in terms of technological advancement. On the software side of things, the technology, the platform side of things, we see here how long it took to get 100 million users to use a platform. And Netflix, it took 18 years, Facebook 4.5 years, ChatGPT had 100 million users inside of 2 months. So the good thing there is we do see that as we have new employees entering our workforce that are more technologically adept, that are more willing to try things, we're able to go and see a much faster adoption of these technologies come into play. We'll look at things like Spec GPT, where we can have the AI that's geared towards specifications in general, not a general purpose tool like a Chat GPT or a Microsoft Copilot, but where it's geared towards getting a detailed specification for, in this case, a roof installation, or Room GPT, where we can go and simulate what this design is going to look like. That's really small scale, but we can take it off to the biggest scale projects that we're talking about. I think we'll see a lot come with blockchain here still. When we've worked with 2D plan sheets, we've had different redlining and markup, and we've had PDF review. We move to model based, all of that becomes ineffective or totally unusable. And so now we need to track changes to those models over time. And so additional technology like blockchain will definitely come into play. And then we'll see some significant uses for IoT, the Internet of Things, a lot of sensoring type options and capabilities, and we'll see that happen throughout again the entire life cycle, from early on in some of the construction and project monitoring to assessing site safety and health, to seeing that assets that are in place are working well and haven't become uh, incapacitated in any kind of way, to alert and reporting systems. And so our infrastructure, our overall development will be that much smarter. When we've got these kind of models to it, it allows us a new way to interact. We can kind of teleport ourselves into a situation. And so here we see with a detailed model of a structure that we can be right at that structure and assess conditions and understand what is happening with that asset. We can go and get super detailed information, an understanding about condition, and do an inspection from models that have been created all from photographs. This isn't video. This is an actual. It's a video of a model that's been created purely from photographs. You know, I think that allows us to look at a couple other areas, specifically like workforce. We talk about a shrinking workforce and how we need to be more productive and more efficient. I've used this slide a couple times in the past. Three pictures of three different conditions here, where these three people are probably not generally employable in our inspection and construction field inspection type work. A lady in a wheelchair, maybe a really well trained engineer, is not able to get into the positions that she needs to be able to inspect and analyze and project manage. And with some of these digital twins, she could be out there. The lady in the middle maybe has been out there and done all this field work in the past, but her condition as a pregnant woman right now uh, doesn't allow her to put herself at risk that way. And the gentleman on the right, he may have done this work for 40 or 50 years, and right now is at the time of his life, from crawling around and through bridge beams and all over, that his body physically limits him from being out there, but he's got all this experience that we need to be able to leverage. And so how we can kind of teleport these individuals into those environments can be extremely valuable. One of the last main things that I'll hit on here, I think, is about a level of openness and data sharing. IFC is really big. It has to become something that's bigger and more foundational. That's industry foundation classes, really allowing data to be shared between vendors, between solutions across the entire life cycle. And so, what we do in making the data, the information more available, allowing collaboration, allowing clarity and intent of what specific images are, specific items in a plan are, and helping out with automation overall. Now we see so many advances here, so many things that will continue to grow and that will be affected by technology. How we go and market new engagements to the general public and show them what we're intending to do with our heavy civil and infrastructure work, simulating that, working with design reviews in new ways on models and not just on 2D plan sheets, and in going through the construction rehearsal and making sure that everything's going to be on site and what has to be updated based on time, using those models then in the future for inspection and different types of immersive operations. We see the beginning of this. We're starting to see benefits with different projects, significant savings on like this Elk River job with digital delivery, avoiding network relocation costs and additional time for projects based on digital twins of the development, and doing the construction pre-planning and rehearsal, saving in field inspections. So over and over, we start to see examples, places where all of us can come in and work the challenges and use the different trends and opportunities for what we see as possible here. So I think wrap up here. Tomorrow, the day after, this year, next year, we're going to see more of this. Hey, road design GPT. Here's some real specific consideration. Give me a digital twin of this with all of my estimated quantities and all the construction phasing, and a model that could be used for operations. We'll see the infrastructure that we are putting out there being that much smarter and providing alerts when there's different situations that occur. We'll have more detail, like a pavement section here, that not only we identify that there's a condition there, but that we've got more historical information about when we installed that and what the conditions were, and if there's other things that we need to go and correlate with that and look into because they may be related. And then we'll see just more about the smart infrastructure, the IoT here coming, that we've detected that there's equipment on site, or that we've got materials there, or that we're ahead, we're behind, and how we need to dynamically change the plans that we're working. So ton going on today. I think that we will see such rapid advances here because of the willingness of this next generation of workers to adopt the technology and allow us to really take it forward.